So our next reaction, we're going to be looking at metal carbonates with acids. So our generic equation, let's start with that. So we have a metal carbonate with an acid producing a metal salt, or just a salt, with also water and carbon dioxide. So instead of just having two things produced, we have three in this equation. So remember, metal carbonate, acid, salt, water, carbon dioxide. So just looking at our generic equation, just so you can see the breakdown of it, our metal carbonate, remember, it can either be a solid, or if we've already got it in solution, so we've got the powder and we've put it into water, we put that as an aqueous solution, so AQ. Our acid in aqueous solution, or we can also have it as liquid. If you want to check that, check the video from your last video that you should have looked at. So now we've got our metal salt. So remember, our metal always comes first and pairs up with the part of the acid to produce our metal salt, or just our salt. And now we have our acid, the hydrogen from that acid, comes over to the water, and we have the breakdown of this carbonate, so CO3, into one oxygen atom and carbon dioxide as a gas. So we have our metal salt, metal, acid, part of the acid, so metal salt. We've got our water, so the hydrogen comes from the acid, the oxygen from the carbonate, and our carbon dioxide gas. This is what we'll be testing, similar to the pop test basically, but when we actually light the match, what we'll be doing instead is putting it near the top of the tube, and it will actually put the flame out instead of having that pop that we had with the metal with an acid. So remember, we're starting off with a compound here with another acid, and then we're moving it along. So we've already gone through balancing. If you're still unsure of that, head back to the last video. We're going to go straight into an example then. So we have a potassium carbonate and sulfuric acid, which will produce potassium sulfate, water, and carbon dioxide. Remember, similar to your metal and acid producing your salt and hydrogen, your water and carbon dioxide will always be produced. This is the only thing that changes in name. So let's look at the actual reaction. So we actually have it balanced. So we have our potassium carbonate, so we have K2CO3, and this is a solid, say we have it as a powder. We have our sulfuric acid, H2SO4, and we have produced now our potassium sulfate, so K2SO4, remember this is in solution. We have our water produced, so H2O, remember the O comes from the carbonate. And we also have our carbon dioxide produced, which is our gas that we test for. So just to make sure that you've got everything balanced, because this equation has actually been balanced, we have to make sure that our reactants and our products match up. So just zooming out a little bit, we have our potassium. We have 2 on this side because we've added that extra little 2 there. So we have 2 reactants on this side, 2 products on this side. Done. We have 1 carbon, 1 carbon. We have 7 oxygens, so 3 and 4. 4, 1, 2. Done. We have 1 sulfur, which we have in the sulfate ion, so 1 and 1. And finally our hydrogens. Do we have those balanced? We have H2 and H2. Done. So if you're still having a bit of trouble with this, just put your hand up and I'll come over and give you a hand with it. just remember, when you're actually doing a lot of these equations, you have to remember the valencies. So remember, nitric acid produces a nitrate, which has a valency of -1. Hydrochloric acid produces a chloride, which is a -1. Sulfuric acid produces sulfates, which is 2 negatives, so you have to have 2 positives to go with that. And our carbonate as well is 2 negatives. So that's why when we look here at our potassium carbonate, so remember our swap and drop rule. So what we actually do, so imagine there's a little 2- here. So we swap it and we drop it. So the 2- means that this now has to change. So if we do swap and drop, remember your potassium is only 1. So we have to make sure that it's balanced. So if we have 1 charge here and we have 2 charge here, we swap it and drop it. So if we go crossways, so 2 comes over here and your 1 goes over here, we don't need to write the imaginary 1, but we do need to write the 2. So we have 2 potassiums now with 1 carbonate. So 2 positives, 2 negatives, we have our 0. Done. After this, we'll be looking at some other reactions. We'll be looking at precipitation reactions, but all of them will follow the same general formula. We'll be looking at reactants producing something, and we'll be able to see a reaction happening.